6-3 binomial radical expressions. Where we're going now. When you compare that to 6-2, 6-2, you were doing a lot of simplifying radicals and multiplying and dividing radicals. What 6-3 is all about is now you adding and subtracting radicals. So, adding and subtracting radicals is very similar to adding and subtracting like terms when it comes to variables. Let me just put it to you this way. Very simple way of me explaining what we're about to do. If I were to give you something that said something like this, 5xy plus 2xy, is it possible for you to add those together? Yes. Yes, it is, because those are indeed like terms. They both have the xy's right there. So if I have 5xy's plus 2xy's, I have a total of 7xy's there, right? Makes sense? Makes sense. We know this. But if I asked you to take negative 4x and add 3y, this technically is already simplified, right? Because you cannot combine unlike terms. Well, the same is true with radicals, okay? With radicals, we follow the exact same principles. Is if they have to, what does it mean, and we'll look at that. What does it mean to have something be a like radical versus a not like radical? So let's just take a look at what a like radical is and what unlike radicals are. So that's our objective here in this lesson here. Let's add and subtract radical expressions. So, right over here. Like radicals, radical expressions that have the same index and radicand. Lots of lingo there, but here's what we're talking about. Same index, and so the index that we're talking about here would be this right here. See how they both have a 3? They also, in order for you to be able to add them and combine, because remember in the math biz, combine always means add, they also have to have the same radicand, which is the number that's underneath the radical symbol. Okay, so here I can combine those together. These have the same radicand, and they actually have the same root, right? And what kind of root is both of those? Yeah, we think of those as being square roots, right? Those are supposed to be little 2's right there. But if you look over here at the other examples, like radicals with variables, there's 2 situations right there where we can also combine those together. I mean, take a look. Do we have the same index? Yes, we do. Do we have the same index? Yes, we do. Do we have the same radicand? 5xy, 5xy. Yep, and 9x squared y, 9x squared y. So when you write your solutions, notice that your solutions here are going to have the exact same radicand and the exact same index. We treat this just like terms, ladies and gentlemen. Okay? So, ultimately what we have going on here, let me do a lot of erasing here. Think of this as being absolutely, and I mean absolutely no different than if we had, say, 1x plus 3x would be 4x, right? 1x plus 3x would be equal to 4x. It just so happens that this x that I just covered up is identical radicals with identical radicands. So I'm really taking here essentially 1 square root of 2 and adding 3 more square roots of 2 for a total of 4 square roots of 2. I have 1 cube root of 7 minus 5 cube roots of 7, which will give me a total of negative 4 cube roots of 7. We are just combining like terms. I have 1, once again, of these square roots of 5xy. I'm adding 8 more of that exact same radical, so now I have a total of 9 of them. And then I have, hey, look, 1 again. I think they want to hammer home, ladies and gentlemen, as you look through this lesson, as you look through the homework, be cautious of that 1 being in front of some of these radicals here. A lot of students kind of miss that, and they end up incorrectly adding these together. And they love to write, say on this problem right here, they love to write a negative 8 right there because they aren't even looking at that right there. But you know better, right? It's really saying 1 minus 8 to give us negative 7 of those. Okay, so unlike radicals, that'd be something like this. Me taking the square root of 2 plus the square root of 3, that is not equal to the square root of 5. Here, let me show it to you with a calculator. So there's a screenshot right there. Me taking the square root of 2 plus the square root of 3 should be about 3.14. Hey, pretty close to pi. Okay, but if I actually took the square root of 5 on its own, notice that decimal is not even close to being the same as the other decimal right there. What the difference in the decimals are showing here is that these two quantities are not equivalent statements. So you cannot add up the radicands when you are doing these. Okay, so looking at problem number 1 right over here. What is the simplified form? So the first thing that you're going to have to successfully do is look and make sure, are these like radicals? And sure enough, these are like radicals. Okay, and because these are like radicals, all it's really essentially asking us to do is to take that 3 and subtract that 2. And wouldn't that give us 1 of those square roots of 5? Don't put that 1 right there. Remember, the most simplified answer there that we can write there would be just be the square root of 5. Take a look at this one. Take a good look at this one. What do you notice? I see a square root of 7. And front row, we see a square root of 5. So since the radicands are different, you cannot combine those. That is technically what you would write here is when you write your answer is you would write that this is already simplified. You can't simplify that anymore. What about C? Can we simplify that one? Take a good look. And I think we can, right? We have the cube root of 7xy. A fifth. No! Admiral Akbar, please. It's a trap! Right? Because that's a 3 and that's a 5. You cannot combine those together. They're going to try and catch on that. So even though the radicands are the same, notice that there's fifth root, third root, or cube root. So you cannot combine those. So what we would say here, once again, this is simplified. Alright? So this is your turn. I will actually pause the video this time. It shouldn't take too long. Go ahead and give those 2 problems a try. And remember, if you can simplify it, go ahead and write the simplified answer, much like what we had right up here. There was a simplified answer. If the answer cannot be simplified, just go ahead and write simplified right there for it. Okay? So let's do that. Go ahead and give yourself about a minute or 2 to give that a try. Alright, how'd you do? So if you didn't pause it already, go ahead and pause it, give them a chance to do it, because I'm about ready to show those answers. Alright, so taking a good look at this one, that is a cube root of 5, that is a square root of 5. So guess what? This is already simplified. And if we take a good look at this one, that is a square root of xy, and that is a square root of xy, so it is okay to combine like terms, and if I have 3x plus 4x, even better. Those are like terms that can be combined. So 3x and 4x, I believe I would have 7x of those square roots of xy. Okay, so there's problem number 1. Not too bad, right? So on a couple of these problems here, they're just going to ask you to combine those like radicals.